So we're going to go over some of the questions from the review. Remember, if you have any more questions that you want me to go over, just send me emails or remind messages. But let me know and I can go over more stuff. All right, so our first question is two parallel lines are cut by a transversal as shown below. So we have a pair of parallel lines, and so we can mark them as being parallel, maybe with a color that we can actually see. So remember, parallel lines have a little arrow indicating that they're parallel to each other. So if you have two lines that have arrows, that means they're parallel to each other. So angle 3 is 61 degrees. So I can label that. Oh my God. 61 degrees. So I can label that in my picture. Maybe I'll make the picture a little bit bigger, actually. Move my little arrows. Now my arrows are a little off kilter, but whatever. So angle 3 is 61 degrees. So we want to find angle 5 and angle 8. Well, angle 3 and angle 5 are alternate interior angles, which means that they're going to be congruent to each other. So angle 3 and angle 5 are congruent because they're alternate interior angles. So that means that angle 5 is also 61 degrees. Angle 8, angle 5 and angle 8 are a linear pair, so that makes them supplementary. So that means that the measure of angle 5 plus the measure of angle 8 equals 180 degrees. Well, we know that the measure of angle 5 is 61. So 61 plus the measure of angle 8 equals 180. So we're going to solve for that. Minus 61 on both sides of my equation. So I get that measure of angle 8 equals 119. That should have all been in, whatever. That should have all been in green, but oh, I can change it. Really? I can't? You're annoying. Why can't I change it? To change them one by one. Nope, it's just not doing it. Come on, thing. And so this is the work for solving for angle 8. Make sense? So when you have these parallel lines, you can the ones that look acute are congruent to each other. The ones that look obtuse are congruent to each other. The ones that look acute are supplementary with the ones that look obtuse. So even if you forget the angle pair names and the facts, you can use the way the picture looks as a guideline because you can remember if you have parallel lines, all of these angles are either congruent or supplementary. There's only two numbers here. Every single angle is either 61 degrees or 119 degrees. You just have to know which one. You just have to figure out which ones. Uh, so angle 7 and angle 3 are corresponding angles. Angle 2 and angle 3 are a linear pair. Angle 2 and angle 8 are alternate exterior angles. So you have all those angle pairs, but if you forget your angle pair names, at least you can recognize the relationships and say, I know that they have to be supplementary, or I know that they have to be congruent, and that'll get you through the solution. Maybe not the explanation perfectly, but depending on the wording of rubrics and things like that, this question is just checking whether you can find the measure. It doesn't ask you to tell me how you found the measure. So I don't care if you, I mean, I do care if you know the angle pairs, but for this question, I don't need to know that you don't have to show me the angle pairs for this question. You just have to find the numbers. You just have to identify what's congruent and what's supplementary. So next question, this one is use the given information to prove that A is parallel to B. So I want to prove that these two lines are parallel to each other. I don't know that they are. I want to prove it. I know that angle 5 is congruent to angle 4. So it's a proof. So I need to have statements and reasons. So statement 1 is going to be angle 5 is congruent to angle 4. That's true because it's our given information. Statement 2, well, angle 5 and angle 4, so I'm given that. So I'm going to go mark that on my picture because if you're told that something is congruent, you should mark it. So statement 2, I want to use that information. Well, what angle pair are they? Those are alternate interior angles. So the converse of the alternate interior angle theorem is that if you have alternate interior angles that are congruent, then you must have parallel lines. So A must be parallel to B. So sometimes it helps to kind of go backwards and put your reason before put your reason and then go back and fill in the statement, because you say, okay, well, I'm going to use that information. How am I going to use that? Well, they're alternate interior angles. So that means I must be using the converse alternate interior angles postulate theorem. What does that tell me? That tells me that the lines are parallel. So this is a super short proof. There are some really, really short proofs that are just going backwards. So basically it's, can you identify the angle pair? And when you're in ALEKS, it has drop-down lists, so you can go find those theorems and postulates and stuff, properties, all that jazz. Now this one is this is another solution problem. You want to find the values of z and x. Uh, so let's stop using Christmas colors. It's not Christmas anymore. Um, so I'm going to go over here. I'm going to make this a little bit smaller because I can't click on top of the pictures. So I'm going to go over here. And so the 75-degree angle and angle Z are same side interior angles. So those aren't the names of the angles, but because there's no points named, I can't actually name those angles. So I'm just going to refer to them by their measures. The 75-degree angle and the Z angle are same side interior angles. So they're supplementary. And then I can go set up my equation based on that. So if they're supplementary, that means that 75 plus Z equals 180. So we subtract 75 from both sides. I said I was going to stop using Christmas colors, and I'm back to green. Because the text box is still on green. Z equals 105. So that's the easy one. The Z angle and the X angle are vertical angles. So now we will pick a not Christmas color. We'll go purple. That is not how we spell congruent. So the Z angle and the X angle are vertical angles, so they're congruent to each other. I'm gonna not draw through the thing and make it look like a plus sign, but you get what I'm doing, hopefully. And we're gonna go, so congruent means that they equal each other. So Z we already know is 105. So 105 equals 6x minus 99. So I want to solve, I've got a two-step equation. I want to solve, so I want to get x by itself. So that means I want to cancel out, I need to cancel out the 6 and I need to cancel out the 99. Visually, so you're doing reverse order of operations, but visually, it's kind of, to me, I think it's easier to think of it as I want to get rid of the stuff that's farthest away from x. So I want to get rid of the 99 first. So I'm going to add 99 to both sides of my equation. So I've got 204 equals 6x. And then I'm going to divide both sides by 6. And I have no idea what 204 divided by 6 is off the top of my head. So I'm going to go ask a calculator. $34. So 34 is x, and that is my answer. And so that's what we were finding. You could plug x back in to find the measure of the angle, but we already know that the measure of the angle is 105. So in a problem in this problem, that is pointless to do. You're just being asked to find the variables. Some other times you'll have problems like this where maybe they're both variable expressions more than just the variable themselves, and you have to actually do some solution steps. But in this case, you're finding the measure of the angle and then using that measure uh, to find the variable instead of the other way around. And then this one, so I've got two parallel lines cut by a transversal, and angle 2 is 125 degrees. So angle 2 is 125 degrees. So I'm just going to label that on my picture because that makes it a lot easier to keep track. Because then I can scroll down. Make sure that you're reading this, because I remember in class I had students working on, you guys had an assignment, like just a regular classwork assignment that had this problem in it. And I remember some people were asking me for help on this problem because they just hadn't read the top line. So make sure that you're reading very carefully, because some people literally, they went to do this and they're like, I don't know what the degree is. I have no idea how much anything is. And it's like, well, just look back up. It's 2 is 125. And then they realized, oh, I know how to solve this problem. They were just missing that information. They just hadn't read it carefully. So now we're going to look at angle 2 and angle 3. So angle 2 and angle 3 are corresponding angles. Nope, I don't have any space. Xbox. Angle 2 and angle 3 are corresponding angles. And corresponding angles are congruent if the lines are parallel. So because the lines are parallel, that means the angles have to be congruent, which means angle 3 is the same measure. So angle 3 is also 125. Now we're going to look at angle 1 and angle 2. So angle 1 and angle 2 are, let's look at this. Okay, so draw tool. So angle 1 and angle 2, or sorry, angle 2 and angle 3 are, let's not have that get cut by the, so angle 1 and angle 2 are vertical angles. So they're also going to be congruent to each other. Vertical angles are when you have the intersection of two lines. The angles across from each other are going to be the same size as each other. So they're also going to be congruent. And it's also going to be 125. So now angle 1 and angle 3 are okay. Angle 1 and angle 3, if they both are 125 degrees, they're both congruent to angle 2. That means the transitive property tells us that they are congruent to each other. We also see that they are alternate exterior angles. Angle 1 and angle 3 are both on the exterior of P and Q, and they're on alternate sides of D. So they are alternate exterior. And then so the relationship is that when parallel lines are cut by when parallel lines are cut by a transversal, oh my god, I can't speak. When parallel lines are cut by a transversal, alternate exterior angles are congruent. So these two, there's a chance that I did those backwards, but from the wording, I'm pretty sure that that it goes this way. But so this question is about identifying the relationships between the given angles, just so make sure that you're careful about keeping track of what angles you're looking at. Sometimes you'll have angles that are supplementary. So if one of them is supplementary, then this one's going to end up being supplementary. So if you have a linear pair and corresponding angles, then you'd have a pair of supplementary angles. So it just depends about what angle pairs you're looking at. But this is basically walking through the proof of why the angle pair relationships work, because the angle pair relationships are based off of corresponding angles and either vertical angles or linear pairs, depending on what branch of geometry you look at. Some versions of it will take the same side interior angles being supplementary as your given basis, because I think that's how parallel lines, that's one of the definitions of parallel lines is actually the lines that make same side interior angles be supplementary. But it makes the proofs a lot more annoying. It's a lot easier to work with the congruences. So a lot of times we take the corresponding angles as being our basis here, because the intersections are a copy. So when you have parallel lines, you just translate the whole line up, the whole angle. So if you translate it because the slope didn't change, then that means that the angle stayed congruent. So the corresponding pieces are going to be congruent to each other. That's the thinking there. And I think that was the last one that I had from last period. So I'm going to check real quick and see if any of you sent me any more questions to go over. Otherwise, I will stop recording and stop presenting. Did anybody send me anything? I don't